Hi everyone, in this talk we're going to be talking about a very special type of function. It's called an inverse function. So let's imagine that we have a certain function called f of x. Is there a function such that f of g of x would be equal to x? It turns out there is, and this function is called the inverse function. So what it's saying is that if we call, this is f, and we say g is the inverse function, or f inverse, that's how we denote an inverse function, of x, this is just equal to x. So what examples can we think of where this is true? Well, let's say that f of x is equal to x squared. Then we say that its inverse would be the square root of x. We can prove this because if we say that x squared is our f of x, so we do x squared, and then f of x of f inverse x would be our square root. Well, this is just equal to x. So therefore, these two are inverses of each other. Likewise, we can say that the square root, f inverse of f of x, this is also equal to x. These two are inverses of each other. Now, what's very important to remember here is that this is only true when x is greater than 0. Because if f is less than 0, we get problems. Let's say that f of x is equal to 4, okay? Well, that means that x could either be 2 or negative 2. But that means that the inverse function, so f negative 1, f inverse of 4, that could be either 2 or negative 2. A function cannot have two possibilities. In order to prove this, we're going to use the horizontal line test. Let's look at a function that looks something like this. We know that this function is invertible because it always passes the horizontal line test, meaning that the function does not cross a horizontal line at 2 points. But if we look at the graph of another function, such as this one, well, this fails the horizontal line test because it crosses horizontal line at multiple points. That means that this function is not invertible on the whole domain. It can be on certain domains, such as from here and on. So what is this telling us? Well, it tells us that when we take inverse functions, what we're really doing is switching the x's and y's, or the domains and ranges of the function, so that the domain of a function is the range of its inverse. Likewise, the range of a function is the domain of its inverse. Using this knowledge, we can find inverse functions. So let's say we're given the function that f of x is equal to 2x plus 2 over x minus 1. In order to find the inverse of this function, we know that y is equal to 2x plus 2 over x minus 1. since the range of the function is the domain of its inverse, and likewise vice versa, we can simply switch the x's and y's and then solve for y again. So when I do this, I'm going to label this x is equal to, and I'm going to use y inverse just so that we remember we're solving for the inverse. So we have 2y inverse plus 2 over y inverse minus 1. Now simply pull this over to the other side, and we get that x times y inverse minus 1 is equal to 2y inverse plus 2. Now simply distribute this out, and what we get is x y inverse minus x is equal to 2y inverse plus 2. Now I'm going to subtract 2y inverse over to the other side and add x to the other, so that we get x y inverse minus 2y inverse is equal to 2 plus x. Now simply divide out y inverse from this side, and we get y inverse times x minus 2 is equal to 2 plus x. Now simply divide by x minus 2, and we get that the inverse is equal to 2 plus x divided by x minus 2. And so now we found the inverse of our original function, 2x plus 2 divided by x minus 1. And so we can see that inverse functions are very helpful, and that we're simply changing the domain and ranges of these functions, taking the range of our function and making it the domain of its inverse, and vice versa.